Welcome to a new episode from CloudTalk in Arabic, but this time in English. In English because we have a special guest, Christians. Hey, Christians.
Hey Gandhi, how are you? Thanks for having me today.
Thank you. Christians is our cloud expert specialized in network, resiliency, and infrastructure. And today we are talking about cloud resilience and cyber resilience. Can you first, Christians, tell us what's the definition of resilience in general and what is the difference between cloud and cyber?
Of course. So I would say that look at resilience as the ability of a workload and application to resist to service impairment, right? So it's not about making sure that the application will never fail, because we will see later there
Mhm.
will always be an option to fail, unfortunately, but it's about making sure that the application, when it's impaired by service disruption, it continues to deliver value to our customers, right? When it comes to cyber resilience, is the difference is that we are talking about the resilience of the data itself. So, for example, how to protect ourselves from ransomware, how to protect ourselves to data loss, and so prevent all that kind of activities, right? It more tied to security. So protect, discover what is there in terms of attack surface, threat detection, and then making sure that if anything happens, we can recover. And so our data is resilient and is resilient.
And
Perfect.
how does it differ from, like, how does resilience differ from disaster recovery, or do they overlap in some way? Because I see some organizations like conflate them, right?
Yeah. That's a great question, Akram. Thank you. So we need to think about resilience as a mental model where we have three verticals. So I would say availability, disaster recovery, and then continuous testing, continuous iteration, right? So availability, we measure the availability of the application throughout time. So we have, for example, a range of time, and we measure that in the famous nines, right? So we know that 99.99% means something, and so on and so forth. So the availability of the application throughout a week, that's measured in percentage. When it comes to disaster recovery, is the ability that we have implemented in the application itself to recover from a disaster. Disaster can be a natural disaster, it can be different category of failures. We will see it later. But how do we recover? Are we ready? And that's measured in RPO, RTO, recovery point objective, recovery time objective. How much time do I need to recover? How much data can I afford to lose, right? And then the most important thing I would say is testing a continuous iteration. If you never test your disaster recovery, if you never test your resilience implementation, you don't really know if that is going to work when your application is actually impaired, right?
Perfect. Let's dive deep in the content prepared for today, Christians. And I believe we will address a couple of these topics in the next slides.
Yes. So, like we were saying, right, the real question is not whether the application will fail or not. Dr. Werner Vogel, at the Amazon CTO of Amazon, always says everything fails. It's not just because he's a negative person. It's because everything will always fail, right? So it's a matter of understanding and embrace failure so that we make sure that the application, like I said before, it absorbs the failure and continue to deliver the value to our users. That's the most important thing that I would say is the difference between understanding resilience and just following the best practices and just following the guidance, right? So everything will fail. And because everything will fail, the cost of failure is very high. We can see here that there are a lot of service disruption and service impactful on the revenue of our business if we are impacted by failure. So we have a bunch of data here. I'm not going to read it through. You can see, we can stop the video and see on the screen. But just imagine that your application will serve a purpose, will deliver a service. You need to understand what is the cost for yourself, for your organization, to make sure that you invest in the best way possible in resilience, because it's not just one blanket fits all, right?
Yeah, and I believe also the impact not only on dollar value, like reputation impact, customer trust.
Correct.
That's to gain back again if we have such a situation.
Yes, correct. The question is, if failure is inevitable, like we said, right? What are the actual selling? What are we actually selling to our customer? We're not selling the uptime. The uptime is just a metric, right? It's saying that we're selling a metric. It would be a lie. we are selling trust. Like you said, exactly, the brand reputation, right? Trust is really important.
And Kirsten, how should customers like balance between resilience and the cost requirements, right? Like, because sometimes maybe something will override the other, or maybe they need to balance them in a way that not something override the other, right? Like,
yeah, that's great. Yeah, that's a very important question. So you should do a business analysis of how much that would cost to you if your application would be down, for example, 1 hour. So if in 1 hour you lose $10, then probably it's not really, worth to spend 100,000, 200,000 in resilience, right? But if 1 hour costs you 1,500,000 or so on, or similar to that, then you start thinking, oh, okay, so the cost of my insurance, which is the resilience implementation, is worth my while because the brand reputation, like Gandhi said, and then because of the delivery of the service to our users. So that's the question. I always ask back the question: how much is the cost of downtime for you in 1 hour, if you're wondering, right? And then from there you can apply different tiering on different, and you will see later, on different applications. Not every workload deserves RTO 0, right? RTO, recovery time objective, how much time it needs to be up and running, right? Back from a disaster, right? So we should treat our application and put them in tiering, right? Because if you have a research or testing environment, that probably doesn't need tier 0, right? It's not critical, it's not mission critical.
Yeah. So usually we use this matrix to classify applications, and based on that we assign RTOs targets.
Yes, correct. The same is valued for RPO as well, right? So we should have, through a business analysis, we should have identified what are the critical application, and based on the critical application, we then identify how much cost is the downtime related to that application. Then based on that, we have the ability to make a more informed decision to understand how and where implement resilience. So another important thing I want to say, resilience, I know this would be controversial a little when I say it, but resilience is not equal to reliability and is not equal to availability, right? So
that's always pursued like that. I mean, when I have conversations with my friends and colleagues, like around resilience, they use sometimes the word availability while they are mentioning the resilience posture of a certain workload. So it's very important to differentiate that.
Yeah. So the availability percentage of time, right? Measured in time or workloads that operates as expected. Meaning, practically speaking, how many requests I return to 200 OK to my users, right? How many requests I serve correctly. When it comes to reliability, is the ability to perform the function, so the value that you're selling to your user, in a correct manner. So it works, it's consistent, and it delivers all the time. The resilience is the ability of the same workload to resist to failures. So I have a failure, I embrace the failure. Is my application still able to deliver the value of my organization? No, then go back, do your homework. Yes, it's resilient, right? That I would say that's the thing, right? And there are different ways to do this, like cross-region replication, multi-AZ, multi-region, but not all of them fits all of the workloads. Like we said before, together, we need to understand which one is the one that requires A, B, or C, for example. Now, RPO and RTO are commitments. They're not aspiration, right? It's if it is an aspiration, it's wrong. So you need to define this as a policy to understand, based on what we just discussed, the cost of downtime, brand reputation, the tiering of the application, the value to your users, to understand what is your last good state, what is the operational wise of size of your application, how is it consistent throughout time, and then how is the service restored in case we have a service disruption, which is different from a service impairment. Service disruption, such as like a disaster or something like that, right? So how much time do we need? And then once we have that, and we have assigned that to different tiers, like we said before, we have a better understanding of where we stand and how we should treat the resilience.
Here there's a questions usually I ask myself when I'm doing some exercise around RTO. So I have an application. It is important, but we have the privilege to, for let's say hour, 2 up to 5 hours of RTO. Let's say if something wrong happen, what are the baseline? Do we have like a global standards or international standard around the RTOs per classified application, let's say critical or non-production?
So there are some templates we can use, right, that we have established based on feedback and based on years of experience and working with our customers and partners. So for example, I would say RPO 4 hours, RTO 4 hours would be like not mission critical, but would be like a tier 1, right? It depends as well on how you're tiering the system. And what I mean by that is that you as a user, as an architect, you have the possibility of choosing your tiering. So there's not a very defined manner to do that. I would say that's why the business analysis is very important. And that's why we need to establish those based on the requirements.
It's more of business decision, right? The technical part is more the execution here and the technical feasibility of these RTOs and LPOs target. But the business should decide how much time I can leave the workload down and not annoy my customers, or I'd say acceptable amount of time.
I believe also, as you mentioned, Kristen, the business requirements and the business impact analysis will affect a lot, like the RTO, RPO values, because at the end of the day, it's you work backwards, and it's the customer requirements. What do they need? What's the compliance they are adhered to, and all of these things affect like these values. I don't think it's something that fixed universally. It depends a lot on what the customer is like requirement.
Yeah, there are guidelines, that, like we said, that we can expect. If it's a mission critical application, to be near zero doesn't exist, right? 10 minutes, 5 minutes, 15 minutes. But then again, not all of the application requires that. And like you said, very correctly, you need to understand your business to define those policies so that you don't waste money investing. It's never wasted, but you don't invest your money in the wrong application, right? You should invest it in the one that it's vital for your business and for your user. There are applications like, that are up and running for the emergency system, for example. So if you're an architect that build that kind of application, you want near zero RPO and RTO. And I say near zero because zero doesn't exist, right? So it's always about understanding what are the requirements, and based on that, and make an informed decision.
100%.
So I would say there are 2 pillars and 1 outcome, right? So there are, like in the well-architected framework, we talk about different pillars. One is the reliability pillar, one is the security pillar. So when I talk about reliability pillar, the question that I ask myself is, can this workload perform consistently and correctly under stress? And is it the way that I implement the resilience expected when there is stress, when there is service disruption? So it's very important to test, and it's very important to understand how it behaves under stress.
Kristen, can you tell us a little bit like about what is the well-architected framework? Because some of our users may be new to this concept on the AWS well-architected framework.
Of course, Akram, good question. So the well-architected framework is a group of best practices divided in different pillars, such as, for example, security that we have here, reliability, we're talking about resilience, optimization, performance, and so on and so forth. And all of these best practices are divided in different categories so that the architect can follow them, and it will ultimately, as an outcome, have a best practice architected framework, architected application, so that the application, at least as a fundamentals, as a baseline, follows all of the good, choices in terms of architecting and deploying it. And I decided to combine the security and the resilience pillar here. First of all, because we have you, Akram, such as expert in security, and second, because we wanted to talk about cyber resilience as well. So if I may ask a question, can you define the security pillar, like I defined the resilience? So what is about the security pillar that makes it important in the well-architected framework for our users and when architecting applications?
Yeah, so Kristen, as I mentioned, it's a set of best practices, right? So this also applies to the security pillar. So in the security pillar, you have also a set of best practices that navigates all the pillars of security and let's say the categories of security, whether it's identity and access management, whether it's threat detection and response, data protection, infrastructure protection, network security, application security, all of these. There's a set of practices that you need to follow that will give you like the foundational protection of your workloads in AWS. For example, like in turning on MFA, for example, as simple as that, right? Like don't include your credentials like in your code when you submit like to a GitHub or something like that. And a lot of these best practices give you like the foundational security that can protect your workloads on AWS or on any cloud provider as well.
Yeah, and funny that you mentioned. I was working with a customer the other day, and he ended up sharing that they uploaded the API key to the GitHub repository, and they said, "Oh, but it's private." But it doesn't matter, right? It doesn't matter that it's private because now that
if you're seeing the threat reports from all these cybersecurity providers, actually they are still like the majority of the threats are coming from traditional security gaps. For example, like they are not protecting the secrets, they are pushing it to like public repo, and all of these things. They are still, you will still see customers that are not following the best practices, which is something that we need to advocate for, of course.
And that's why we have the architecture framework that everyone should follow.
Exactly.
Yeah. Questions for both of you around these two pillars. Like, okay, defining them is very clear. Testing them is not clear for me, because testing happy scenario about reliability or resilience or security is fine, but we don't know what happened actually in the real life scenario. So what are the best practices when it comes to testing? I believe on security there's some companies doing some, like, so let's say pen test, or let's say validations on the procedures, etc., but mainly for resilience. Is it as simple as turning down an EC2 instance, for example, and check how auto-scaling will work, or let's say, or maybe DR or Route 53, for example, health checks, or it's more than that?
Well, I wish it was simple as you described, right? So, and that's a great question. So, and it's funny that you brought up the EC2 auto-scaling group and, implementation.
Yeah, because that's the common stuff that
Common.
they talk about it, which is quite entry in terms of level. But what this testing means for the business, for big organization.
I'll give you an example. I work with customer that thinks that the auto-scaling group will save them from a bad day, right? What about control plane being down and all of a sudden your control plane doesn't use the auto-scaling group anymore because it's not capable of launching, right? So then you have implemented auto-scaling groups and you're thinking, oh, that's gonna go and be okay, but it's not, because the control plane, which is the responsible part of control plane and data plane, is not able to launch anything because it's down. So you should always implement with static stability. And this is another concept that more than happy to define in maybe in future session, but static stability in a nutshell is the ability of implementing resilience so that when a service impairment occur, you as an operator, you as a managing admin or whatever, your application doesn't need intervention, manual intervention to scale up, or manual intervention from the operator itself, or manual or automatic intervention from control plane, right? It's completely decoupled so that you don't rely. And there are different practices to implement static stability, right? Going back to your question, there is a service that we use in AWS. It's called AWS Fault Injection Service. I would say testing is very difficult because sometimes because of regulation, because of constraints, you cannot really test. But the word you cannot really test should be completely out of your books, right? You should test, and you should test all your implementation, because you do not know how it behaves when it actually impaired. And not knowing is like it never happened. It just doesn't work like that. You do not know if all of your resilience security works when it's needed the most. And then that's the difference between you being down many hours and having revenue impact, brand reputation, and the difference is in having what I always say, your recovery should be boring. not exciting. If it's exciting, then you go back and check what's wrong with the architecture. So you should test, you should have game days, for example, you should have programmatically injected testing procedures so that you can, in a controlled manner, test your environment and see if everything works as defined. And there are different services such as FIS, Fault Injection Service, that helps you in doing that. But testing is the most important thing. Like we said at the beginning, it's part of the mental model when it comes to availability, disaster recovery, and testing.
Yep.
Okay, so next slide. And that's why we were discussing about resilience and security, right? So cyber resilience. So we want to prevent, we want to detect any attack, we want to respond, we want to recover, and we want to learn from what happened and why that happened, right? There is a very interesting conversation about cyber resilience and investing in security and or cyber resilience. I would say investing in both, because you can protect your environment, like Akram said, but if your environment gets, I give you a very simple example, you get affected by a ransomware and you do not know how to recover, you have to pay the ransomware, right? The fee. In some countries, it's not even legal paying it, so you're not even allowed to paying it, so you lost your data and you are down completely because there's no data. You can recover the infrastructure, there's no data, so you lost all of your work, right? And it's very interesting. If you look at the data right now, there was a study that is talking about, there's a graph that goes up with the number of companies that are paying ransomware, and at the same time is going down with the number of companies that can recover from a ransomware. So we should aiming to change the things, right? And having down the number of companies that are paying ransomware and up the number of companies that are capable of recovering. And there are different ways to do this, right? And I'm sure Akram, you know exactly what I'm talking about from a security perspective. So, and it's
not only ransomware, like a data breach or something that hurts your reputation and the cost and everything, that the cascades with all these damages that happen when a breach or something like that happens.
Yeah. So resilience is a practice. It's not a project, right? Practice meaning you should set a set of objectives, then design and implement those objectives, test, and then I repeat, test, and then I repeat one more time, test. And then once you are tested and you know if you have potential gaps and you learn from that and you fix it, then you operate. And then what you do, you repeat the old and you start again, right? So
it's a cycle, like if you can draw the analogy like the DevOps or DevSecOps or something, like it's the same for resilience. Like you have to test, you have to set the objective and get that feedback loop to enhance the processes and the procedures and the guidelines and everything that you do. So yeah,
I agree. As mentioned here on the slide by Cristian, it's not a project, so there's no start date and end date for that. If any company is dealing with resilience as a stream of project or a wave, that means it's not done in a perfect manner and required to be a continuous working.
Yeah, because it's not finished, right? If you finish to work on that, we completed this, you unfortunately gonna have to say you don't understand how resilience work, or you've never been impacted up until now. And I wish you all the best, but better be prepared. And so how do we prepare? So we design all of this, we implemented, and we have our resilience practice with testing, but how do we really know if we can respect our policy, RPO and RTO, for example, right? How do we know if the MTTR, mean time to recovery, is expected? How do we know if the mean time to detection works so that the mean time to recovery works as well? So I need to know if I set an RPO of 1 hour, right? So I have 1 hour, and then I have an RTO of 1 hour, so both of them, right? Well, let's assume that I know what's going on time to actually have 1 hour to recover my data and to be back online, right?
Mm-hmm.
If the observability detects and the monitoring detects the failure 40 minutes after the failure, then I have only 20 minutes. Do you see how it doesn't work? Like I already wasted 40 minutes. So observability is precondition, is prediction, I would even say. It's not a feature, should be embedded in every resilience implementation. Monitoring should be active and will allow us to know what's going on and act.
And when we are saying active monitoring, that means we don't neglect this topic in terms of talking about zero gap between incident and monitoring, because we cannot afford another KPI like RTO and RPO internally to stack up on top of it.
Yeah.
So ideally, and that should be the case for enterprise and mission critical workloads, is whenever something wrong happen to get instantly notified, right?
Yes, correct. Not just instantly, but even proactively, right? That should be the aim, right? Because you know that something's going on. And I tell you one thing: there are, such as in resilience world, there's a specific type of failure that we address as a gray failure, which means that your dashboard is all green, right? So that happen when you have shallow health checks, which means that they only check the surface, right? So I'll give you an example. You're monitoring the uptime of an EC2 instance, right? And you have EC2 instance, health checks are all perfectly fine, returning to under okay.
Yeah.
Akram?
Or CPU utilization, or all
CPU utilization, yeah, and it's all green, right? But you don't know that the CPU in the EC2 instance is trying to connect to the database in the backend, and the connection between the database, which by the way is up and running, the database is up and running, but the connection is experiencing latency. Mm-hmm. So that is creating a service impairment that you do not see, but your users sees, because they see that there's a lot of latency, a lot of requests that they send to your system are failing, and so on and so forth. So in that case, Twitter will tell you, or X will tell you that something's going on, but you don't know because it's a gray failure. The dashboard is green. So observability should be 3-dimensional and go very deeply. Of course, for the mission critical application, you don't have to implement this for across all the board, right? So it's very important to understand what's going on at different layers of your architecture in advance.
Observability, I believe it's one of the core concepts when it comes to cloud, even for security, cloud ops, infrastructure, anything. Like, you need to be very good with your observability strategy and how you like monitoring your system. It's essential not only for resilience, it's essential for security, for your cloud operations, for your cost analysis, everything. Everything need to be observed and monitored, and you have to have metrics, logs, traces, all of that to end of your systems and workloads.
So, like I said before, if you didn't test it, it doesn't work. Exactly. I don't believe you. You're a liar. Okay. It's not going to work, right? And I'm sorry to be very straight, but test. And I'm saying this because the more you invest in testing, the more you know how the behavior is, expected or not. So if the behavior is expected or not. So if you don't do that, you don't know.
It's like a file trail when you have to do it every while, right?
Yes. So here, a very interesting table, I would say. So of course, the recovery time objective, the lower you want it, the higher is the cost, right? And this is important to understand, right? It depends on your infrastructure. That's why we were talking about business analysis and understanding the tiering system for your application. We start from a disaster recovery strategy that goes by backup and restore. So that's hours of days, and this is always also tying back to the question that Ugandi asked about, do we have a template? This is a template, let's say, right? This is how AWS defined the disaster recovery strategy, and it starts with backup and restore, which has hours and days of RTO, but of course the cost is very low. Then it goes to pilot light, minutes, the cost goes up, and then warm standby, and then multi-site active. Now, for those of you that are not familiar with these terms, backup and restore, of course, I have a backup, ideally not in the same location where your application is running for a series of reasons. And then you run backups every week, every day. It depends on RTO as well, right? Pilot Light, you have, let's say, a secondary location. I don't want to call it region because it could be on-prem, on another cloud, for example, where you are hosting a very limited version of your application. So where, for example, you have load balancing implementation, but you don't have compute, you don't have data, right? So what happens is that when you have to fail over to that, as in terms of disaster recovery strategy, you have to spin up all of the environment. So the compute and the data. Of course, that will take time. That's why we're talking about tens of minutes. Mm-hmm. When it comes to warm standby, you imagine the same situation, but on the failover location, again, on-prem, region, multi-cloud, whatever, you have a reduced version of your application. So where you have like a baseline, and again, here is important to establish baseline by running a business analysis and requirements, but you have like a limited capacity in terms of compute and a very, the data is also there this time, is present, but it's warm, right? So it can be used immediately. But again, it's not all 100% the same as your primary region, right? So that's why it takes some minutes to go back, you know. And then of course the multi-site active, you have a synchronized version of it, and it costs you high.
Question here around the separation of application layer and data layer. If you're talking about, let's say, business applications, sometimes you can afford, let's say, Pilot Light or backup restore on your application layer, but on the data layer you have to have high RPO because you know the data is sensitive and cannot be lost in any way. Do you see these patterns usually available in the market, and how they decouple it?
Yeah, so great question. So I see some customers with big enterprises where they have this challenge. What they do, they use a warm standby or even active for the data, but maybe they don't even deploy the compute layer, right? So they have the data completely ready so that if, for example, their application doesn't rely on any compute in terms of infrastructure as a service, right? They can just use the data from the other healthy target or healthy location, or whatever you want to call it. And of course, this is the way that they decouple. So it's not a one-size-fits-all, of course, but it can be architected in a way to fit the requirements of a specific tailor to your requirement.
Goes back again to the business impact analysis, Cristian, right? Because they need to have all of these discussions early on to decide which applications are more like critical and stuff like that.
Yeah, it will be case by case on application layer.
Yeah, and I tell you one thing, right? I have some customers that they don't even go through the business analysis. They say, hey, we need to be multi-region, active, RPO, RTO, 15 minutes, yeah? And then you ask questions. You start asking questions. And they're willing to pay, you know? You start asking questions, and then slowly they realize, like, wait a second. Oh, are you saying this and that? Yeah. Oh, maybe I don't need 15 minutes. Oh, because this and that. So, and they optimize the cost. So it's one of our pillars in our architecture framework, right? Cost optimization. They optimize the cost. They maybe redirect the spending towards different projects that are more important, and they understand the tiering system. And because not every application needs insurance of us. It's like when you get an insurance for a car, right? You don't get the top tier for a car that it's $1,000 value and it's all 10 years old. I'm just giving you a stupid example maybe, but to understand the options, right? So because we talk about disaster recovery strategy, the question I get a lot of time is, do I have to move region if my primary region is impacted? When do I move region? Do I have all of the feature pairing in the region, target region that I want to move to? So for example, if I'm using a specific EC2 instance in region A, will I have the same EC2 instance that is required for my workloads to operate in expected manner in the region, in the target region? So the question is not about do I move now? Why I move? It's very precisely coupled to the requirements. Why is the business deciding to move to that target region? Is it in scope? Is there a recovery action? Is it not a recovery action? Is it a business decision because of your user presence in that region? So you reduce the latency, increase the performance, and you increase the user experience. What is this? Is it a recovery? So most of the time, if you did your things right, is because you need to recover, right? Is because you fail over maybe during a disaster or service impairment to a different target region, right? But here comes the analysis paralysis. It comes, okay, some customers do not even know because they didn't test. So they don't know how to approach the runbooks, how to create the runbooks, and they are, the teams, not just the technology, the teams are paralyzed by what do we do now, right? And that's why we have deployed the tool that is called Resilience Migration Advisor. That is an open source tool. It's available on the link down below in the description of this video.
Yeah.
And you can download it today, you can contribute, you can use it and abuse it in any way, shape, or form. So what it is a local HTML file, which is standalone and resides on any device that you install it. It doesn't have any backend. It's structured so that in the case of requirements from your point of view, because of a service impairment, you can use it as it is, right? It's built with all of the well-architected framework best practices for all of the pillars, and it helps you generate runbooks. It helps you, giving you a guidance on how you should approach the runbooks and the steps to move, if you need to move, to a target region, right? So what is not, it doesn't move your environment for you. It doesn't do the job for you. It's just an advisor, like the word says, to help you accelerate the move of your workloads to a target region. It also asks you questions so that it tailors based on your workloads and also helps you in a way that is strategized. Let's say, even if it's not, if your region is not impaired, you can use it for help.
So, Christian, it does not access any third-party data. It just asks you like questionnaires, and based on that, leveraging certain framework. You are saying, AWS Resilience Lifecycle Framework to let's say promote certain runbook or process to moving if that's needed.
Yes, it doesn't access anything at all. It's just a standalone. So in conclusion, resilience is not the absence of a failure. We started with this and we end with this. Resilience is the discipline of making the failure survivable so that we continue to deliver our services and value to the customers, right? And on that note, I would like to show my new book that I wrote. All of the proceedings are going to a charity to support cats in distress.
Okay. We are not getting any profit margin.
I don't care. But yeah, this is, there's also a QR code and a code for a 20% discount. If you scan that, the link will be in the description as well. It's about cloud networking, focus on networking and resilience of the network architectures in the cloud. And on the cover, there's my little one that unfortunately passed away. And that's why that was the reason of the book, and trying to give back to charities in the best way I can.
Awesome, Christian. That's a good initiative, actually.
Thank you, Christian and Akram, for this session. I believe we get a lot of knowledge around resilience and the importance of resilience. Call to actions: check the RMA tool, test it, break it. You can contribute as well. It's an open source. And also we have the Cloud Networking and Resilience book from Christians. Feel free to scan the link. Also will be provided in the description of this episode to access it as well. Thank you for your time. See you in the next episode.
Thank you so much. Bye-bye.
Bye-bye.